Okay, folks, simplifying radicals. Now there are two parts to this that we're going to talk about. One, we're going to talk about simplifying a radical, okay? And the next thing we're going to talk about is rationalization. Okay? Rationalization. And I have a little my Shakespeare form of notes. 'Tis is called rationalization. But guys, two things that we need to talk about with today's stuff. First thing, simplifying. Guys, you know this already, but the square root of 4 times the square root of 9 is equal to the square root of 36. We can multiply radicals, okay? And let's, just to check it, square root of 4 is 2, square root of 9 is 3, and this better equals 6, which it does. Okay, so we can multiply radicals, all right? And if we can multiply them, that also means that we can factor them, all right? So, in the notes up here, I use the square root of 50, but right here I'm going to use the square root of 75 just to give us something a little bit different. Okay? Now, I need to do this with every radical that I can. Same thing with fractions when I always want to reduce. With radicals, I always want to simplify if I can. And I'm going to take this and I'm going to prime factor it. That's the square root of 25 times the square root of 3. Okay? Now, this number is prime in its truest sense. I mean, not in its truest sense, but the 3 is prime. I can't break it down anymore. This is root 5 times root 5, and now I can't break those down anymore. So I'm going to write the square root of 75 as root 5 times root 5 times root 3. Now, some of you are already seeing that root 5 times root 5 is the square root of 25, and that's a perfect square. But just a little shortcut. Any time that I have a pair of numbers, they equal the number that's underneath, right? Because the square root of 5 times the square root of 5 is the square root of 25, which is just 5. Okay? But I'm left with this one that doesn't have a pair. So I've simplified that now to 5 times the square root of 3. The square root of 75 is equal to 5 times the square root of 3. And this is the simplified form. We have to do that with all of our radicals. Okay, when we're not giving approximations and we are leaving them as a radical, then we need to simplify it. We've basically taken out a perfect square. 25 went into 75, and 25 is a perfect square, and so we've simplified it to 5. Okay, now that's one part of what we're talking about today. The other part is rationalization. All right, and rationalization means that you can never leave a radical in the denominator of a fraction. So for instance, let's say that I've got 6 over the square root of 3. Okay, now that's bad. I can't have the square root of 3 in the denominator here. Okay, I've got to get rid of it. And there's a very simple way to get rid of it. All I do is I multiply the top and the bottom by that radical. Okay? So on top, I'm going to get 6 square roots of 3 over root 3 times root 3. This is a pair, just like I did when I simplified. It just turns into the number that's underneath the radical, right? Root 9 is 3. Okay? But I'm still not done, because you're going to see that the 6 and the 3 can be reduced. Yes? So 3 goes into 6 2 times, and 3 goes into 3 goes into 3 one time, and I'm going to get 2 square roots of 3. I could put it over 1, but I don't need to. So do you see, we've got to get that radical out of the fraction, out of the denominator. And so we just multiply the top and the bottom by that radical, and it gets rid of it. Okay? All right, good job, guys. See you at example 1.